Okay, welcome to Digital Communications. I think all of you already learned the analog communications, right? So what we are going to cover this course is going to be digital communications. So mainly what we are talking about is digital communications, and we're going to use the same textbook. Most of you covered already the half of this textbook in the last semester, so we're going to cover the other half in this semester, right? Which is mostly digital communications and also some of the performance analysis. So most of the chapter that we are going to cover this semester somehow is the mathematics. So there are a lot of mathematics, especially when you do like performance analysis of communication systems. You're going to end up involving a lot of mathematics. Some kind of special functions such as Q functions. You will do a lot of integration and some of those things, right? So what we're going to cover is those things, but what I'm trying to do is try to minimize those mathematics because sometimes it's very boring, right? So, I'm trying to give you some of the concepts more rather than the mathematics, right? The best way to do is to use the PowerPoint. So what I'm going to do is, some of you remember from the previous semester, is that I'm going to upload the lecture note. Okay, every lecture, every week, just before the day before the lecture, I'm going to upload the lecture note, okay, in the portal site. So you can go and log in and download the lecture note, and if you like, you can print out and bring it, or if you can, then you can bring your laptop with the file. That's okay. And those lecture note will have some of the necessary equations, okay, and some of the pictures and all of those things. Sometimes it's very difficult to write all the equations here or draw the pictures here. So if you can, just bring those things, okay? The first lecture note is already uploaded. So you can go ahead and download it. For the tomorrow's lecture, you can, I'm gonna make sure that upload the second lecture today. So you can download it and bring it tomorrow. The lecture time is today and tomorrow, Tuesday afternoon. And office hour is Wednesday, 10 to 12. So office hour is like this, right? You can come by anytime. During that office hour, if you have any questions regarding this lecture, this course, or anything, so you can just come by. It's basically a concept of open door office kind of concept. So even though my door is closed, you can still come by for any matter, okay? Anything. So that's concept of office hours. If you're not available during the time, Wednesday 10 to 12, you can send me an email with the questions, or you can send me an email for making an appointment for some other time, okay? Yeah, what else? Yeah, that's pretty much it for introduction of this course. So as I said earlier, we have many chapters here, and some of you who learned the analog communication from me, we already covered up to, I think, chapter 8 or 9. I think chapter 8, right? But the problem is that some other did not learn the chapter 6 and 7. So what we need to do is we have to review the chapter 5 and onwards, right? Chapter 6 is noise on analog communications. Did you learn noise on communications, everyone? Yeah. So what we're going to do is we're going to very briefly review some of those things, and we are going to start from chapter 7. Chapter 7 is analog to digital conversion. So that's the starting point of digital communications. But chapter 7 is relatively less important, so we're going to quickly move on to chapter 8 and 9 and 10 and onwards. Okay, so that's what we're going to do. Okay. Okay, so let's get started. Any question about this course? Okay, actually one more thing to say. Since this is an English course, right? What's gonna happen is all the midterm, final exam, or even quiz, everything, the question will be English, and you need to write the answer, all of the answer in English. You know that, right? Yeah, make sure that you write everything in English, even in the exam. Okay, I don't care about the grammar, English. You don't have to make a perfect sentence. That's okay. As long as I understand, that's okay, right? This is not an English course, so I'm not going to check the grammar and things like that. That's okay. But make sure to write in English for all the things when you submit, okay? What else? Oh, yeah. Throughout this course, even though this is a theoretics, right? We learned some of the theory about the communication systems. What I'm trying to do is we're going to do some of the simulations, like some hands-on kind of experience, rather than just learning everything only from the book. Okay? So some of the homeworks will be some math lab simulations. Okay? Maybe sometimes I may call that as a project, but it's basically the same thing. Project or homework, or those are basically the same thing in some sense. So some of the homeworks will be some handwritten homework, but there will be some of the homeworks which require some math lab simulations. Okay? So what you're going to do is you go back and you make your math lab code and run the simulation in math lab. And then you're going to submit the result and print out the graph and things like that. And that's going to be the homework. And I think that that kind of hands-on experience is very important. So probably, I don't remember exactly, but the midterm probably 30%, and final 30%, and those homework plus the simulation thing, those things probably 30%. That's probably how to evaluate this course, okay? Evaluate your score. But all of these things is already uploaded in the portal site. So go to the portal site, okay? Then you will see two files. One is a syllabus, the other is a lecture note for today, okay? You download the syllabus, all this information is already there, okay? Just as soon as you finish this course, finish today's class, and go ahead and download it. And what I'm saying now is already there. Okay. As far as I remember, it's a 30%, 30%, and homework plus quiz plus simulation 30%, and the remaining 10% is probably attendance and things like this. Okay. Yeah. So make sure to download those things. Okay. Let's get started. Okay. We already learned analog signals, right? Actually, we don't have any clock here. 시계 좀 풀어보세요. 여기 잠깐. 10분 빠르다. Okay. We already learned analog communications, right? So what is a communication? Communication originally starts from the information. Okay, communication is like a talking sometimes, right? Or send some of the data to someone else. So there is a transmitter. There is also a receiver. That's a communication. And so those two can be a person. Two different people can talk. That's communication. Or two different machines or two different computers can communicate. Okay? But anyway, there's a transmitter, there's a receiver. And in between, there's a channel. It can be a wireless channel, it can be a cable, or it can be anything. But in between, there's a channel. Okay, we call that as channel. So let's write it here. So this is always basic for every communication, analog, digital, anything. Communication always consists of transmitter, receiver, and channel. Okay? And this channel can be wireless or wired, as I said. And transmitter, receiver can be human, or it can be your cell phone, or it can be anything. It can be any device, any computer, any machine, human, anything. But in order for the communication to happen, what we need to do is, in addition to this, you need to have information or message. Right? You have information or message. Because if you have no information, then this transmitter receiver is just sitting there doing nothing. They do nothing, right? Because nothing to do. That's not communication, right? They're just sitting there. So in order for the communication to happen, you need to have some of the information or message. And this information is delivered from one place to another. That's communication, right? Only in that case you can call that as communication. So like these two guys are just sitting. That's not communication. When these two guys are talking each other, or just deliver some message each other, that's communication, right? So in order for communication, always the starting point is going to be information or message. We always start from this one. Okay? Typically, transmitter has this information. Now, what this transmitter wants is to deliver this information to this guy, to the receiver, right? But this information eventually goes through the channel. Whatever channel it is, we're going to go through it, right? So that's the environment. Now the question is, what is the most efficient way or effective way to deliver this information to receiver, given that there is a channel? Now think about this way. It can be a voice, right? These two are human beings, like these two guys, and information can be my voice. Okay, my voice. And this channel can be like this, wireless channel, some of the air, right? What is the most effective way of delivering this voice through the channel? Like think about this way. If we are very close, like 1 meter away, I can just talk. But let's say he is like 1 kilometer away. Then what is the most effective way? I cannot scream, I cannot shout, still he cannot hear it because he's so far away. So you need to use some other way to deliver your voice to him, right? So depending on the environment, depending on the distance, depending on the channel, depending on everything, you need to use different way of communication. Sometimes just use your voice is okay, but sometimes you need to use some other technique, such as coding or modulation. Sometimes you need some other things. Okay? Depends on the channel, depending on the receiver, transmitter, depending on the message, you need a different way of technique. So that's why there are so many different techniques in communications. But the most basic thing is that this channel, as I said, can be wireless, but sometimes this can be a underwater channel. Think about the submarine. You know submarine, right? Submarine like this. In the underwater, in the ocean, okay, deep ocean, submarine needs to communicate with some other submarine or headquarters. How do they communicate? This is underwater. Okay, water is very different channel than wireless. So depending on the channel, you need to use a very different way of doing it. But information can be same thing. My information is my original message. So information can be same thing, but depending on the channel, you need to make this information in a different way and transmit. So that's where the concept of modulation comes in. So we have a modulation. You learned modulation in analog. Also demodulation in the receiver. In analog communication, you learn the modulation, right? Analog modulation. So what is the example of analog modulation? Analog modulation, AM or FM, PM. Okay, those are modulation like this. But those are analog one, but still those are modulation. Why do you do modulation? Why do you need FM? Why not just send a message like this without modulation? Why do you need modulation? The main reason is this. Think about FM. You have FM radio, right? FM radio, how does FM radio works? You have maybe in the high mountain, you have a FM tower. So this tower transmits FM signal. You are right here with FM radio. Let's say this is FM radio. You are listening FM like music, right? But the distance between these is like 5 kilometers away. Something like that, right? 5 kilometers. So in this kind of case, let's say we don't have any FM modulation. Instead, they just play the music. I cannot hear it, right? Because just the music or voice cannot travel 5 kilometers. If they just play the music, I cannot hear it. Maybe if you are right here, just next to it, you can hear, but you cannot hear from 5 kilometers away. So in order to deliver music or voice over this 5 kilometers over the air, you need to have a modulation. Think about another way. There's a submarine here, right? Another example. Let's say in underwater, let's say we want to do the same thing. In the submarine, we play music, and we want to deliver this music into another submarine, underwater, 5 kilometers away. What modulation do you need? You still need a modulation, but that modulation used in submarine is very different from the modulation used in the air, because modulation is a function of channel. If you have air like this, you need certain modulation. If you are going underwater, you need a different modulation. Maybe in the cable, sometimes you need a different modulation. So that's what does that mean? That means this is a message that I want to deliver, and I cannot send this message as it is. I need to have a modulation, because modulation will change the shape of your message. It changes it into some other waveform. And then that waveform goes through the channel. Air, the underwater, whatever. It goes through the channel most efficient way. And then eventually it'll reach the receiver. Receiver needs to do demodulation. That's the function of modulation, demodulation. Okay? So that's a basic concept of modulation, demodulation. That's why you learn analog modulation, AM, FM, PM in analog. Now in digital communication, all this concept is the same. Everything is same. Only difference is when you do modulation, we are doing digital modulation. Digital demodulation. That's only difference. Everything in the channel is still analog. You know that everything, my voice, everything in the world, everything in the real environment is all analog, right? Everything is real analog. But only the processing, this is a machine, right? Your cell phone. This is like a computer. So in the machine, we are doing digital processing. That's digital communication. Still what is transmitted over the air, analog. All the time, right? What is here is analog. But we are doing analog, the digital processing. But remember, the original information sometimes start from analog, like my voice. Think about this way. My transmitter now, I make it this way. I have a microphone, okay? And this is my transmitter. So what I'm going to do is I'm going to talk over the microphone. Okay? Microphone will record my message, my voice, and then send it to receiver. Think about that case. In that case, my voice is analog. My voice is analog. That goes into the microphone. Inside the microphone and then inside the transmitter, they're doing some digital processing and then transmit. Receiver do demodulation, digital demodulation, and recover my voice. In that case, we start from analog and we change it into digital and then do a digital processing. Okay? Same thing here. We receive we do a digital processing and actually we need to change it back to analog because the air, the channel needs to be analog. So my voice, original voice is analog, change it to digital and do digital processing and then change it back to analog and go out to the channel. This guy received the analog signal, okay, and change it back to digital and do digital processing like demodulation. And then again, going back to analog, that's what you hear. Okay? You hear the music, that's analog, right? Everything in the world is analog. So that's what's going to happen. So first, the starting point when you talk about digital communication is going to be A to D converter. Okay? In the previous analog communication, what's going to happen is I just talk. My voice is analog. And they do analog processing because that's analog communication, analog modulation, and just analog. So everything is analog, right? Because that's analog communication. Modulation analog, demodulation analog, and everything is analog. That's analog communication. But in digital communications, as I said, original one still is analog. My voice is analog, but change into digital by this A to D converter and change it to digital signal. And then you do digital processing, whatever it is, right? Like this, digital modulation, for example. After you do digital processing, we need to change it back to analog because we have to transmit over the air. We have to change it back to analog. Now the receiver do the reverse job. Okay, so that's what's going to happen. So all the starting point is A to D converter. We have to change the analog to the digital. That way we do digital signal processing. What does this look like? What do you need to do in A to D converter? What this guy do is change the analog to digital signal. That's all it does, right? To understand that, we need to briefly look at what's the difference between analog signal and digital signal, okay? So here's the analog signal. Analog signal is something like this. So this is time domain, and this is amplitude. Okay? So analog signal is like you have a continuous time. Also, the value is continuously changing. So that's analog, right? My voice and whatever signal you can see over the air, that's all analog. So it's always continuous. Continuous time, continuous value. The signal will be continuous. However, that's analog signal. What about digital? Digital signal looks very different. This is time. In digital signals, what you do is that now you have something like this. This is just an example, right? Something like this. What that basically means is in time, it's discrete time. You know what that means, right? Discrete time. Not continuous, discrete. Discrete time. Also, the value, the amplitude is not continuous. it always has to be this value or this value, this value, this value. You can never have this value. That's not allowed, right? You need to have only one of these. So that's what we call as a quantization. So you need to do quantization inside the A to D converter, and you need to do sampling. This is called the sampling, right? Sampling. So this sampling and quantization is a main function in this A to D converter. So this A to D converter, as I said earlier, you get the analog signal, you get the digital output. Input is the analog signal, output is the digital, and this analog signal is going to be an input to the A to D converter. And inside this A to D converter, first thing to do is sampling. Once you do sampling, right, you sample it here, here, here. Depending on your sampling frequency, you sample it here. So how often you do that sampling frequency, right? If you have a high sampling frequency, you do like very fast. If you use like a low sampling frequency, you do like slowly, right? But that's a sampling. Whenever you do sampling, you get this value, and this value, that value, and you make a sample and hold like this, right? So that's why you do like, you get like a square, you do like a staircase kind of function, right? That means we have done sampling already. But once you just do sampling, this value can be anything, right? This value can be anything. But that's not allowed in digital signal. So that's why you also need to do quantization. If your value is something like this, then you are going to change this value into one of these. So if you get this, after you do sampling, let's say you get this value, then you're going to change this value into the closer one. This is a closer one, right? So that's a quantization. So the value is also a little bit changed. For each value is a little bit changed. So eventually you're going to get this kind of output signal. That's what we call as a digital signal. Okay? So that's the main difference between analog signal and digital signal. Analog signal is always like a continuous time, continuous value, but digital signal is going to be discrete time. Also the value is discrete. The value also is discrete. Sampling is decided by sampling frequency, and quantization is decided by the number of bits, like for example 8-bit or something like that. So that's why if you can Google it, right, search it in the online A to D converter, then you can see actual chip. And every A to D converter chip, let's say A to D converter chip, will have a specification. Every chip has a data sheet, right? You have a specification. And that specification for A to D converter will always have, like this A to D converter chip is 8-bit with a sampling frequency up to 100 megahertz. You always see these words, these two, okay, always. So that basically means is that this chip can run up to 100 megahertz sampling frequency, okay? And it supports 8-bit quantization, which means 8-bit is 2 to the 8 different levels, 256 different levels. So in this case, I have only 4, but the number of levels, how many levels you have, depends on the bit. So 8-bit means there are 256 different levels. If you have a more number of bits, like 10 bits, that means this A to D converter will have 1024 different levels. So it's better, it's more accurate, right? Because you have more levels. But the problem is more expensive, okay? Consume more power, things like that. So typically 10-bit, 12-bit, sometimes even 14-bit, that's for high-end audio. Very good quality of audio system, you use this kind of thing. But typically the cell phone and these things, you don't need this expensive one. 8-bit is good enough. Okay, that's always what's happening. But you will see A to D converter every single device you have. Okay, every single device. Okay, so that's always starting point of A to D converter. Once you do this, right, you get now the digital signals. Once we get the digital signals, now we can move on to digital processing. And one of the digital processings is modulation, digital modulation. Okay? Okay, so we're going to cover that digital modulation throughout the first 3 weeks or so. So for some of you who already learned the digital communication from me, probably the first 3 weeks is going to be review. Okay, we already talked about those things last semester, but that's going to be review, probably first 3 weeks. Okay, and later on we're going to go into details of the digital communications and what happens when we have a noise. How do we look at the performance of the systems and things like that. Okay, let's stop here today. Any question? Okay, then see you tomorrow.